What does super do in Python? Difference between super underscore init underscore and explicit superclass underscore init underscore. What's the difference between and? I've seen super being used quite a lot in classes with only single inheritance. I can see why you'd use it in multiple inheritance, but am unclear as to what the advantages are of using it in this kind of situation.
The benefits of super in single inheritance are minimal. Mostly, you don't have to hard-code the name of the base class into every method that uses its parent methods. However, it's almost impossible to use multiple inheritance without super. This includes common idioms like mixins, interfaces, abstract classes, etc. This extends to code that later extends yours. If somebody later wanted to write a class that extended child in a mixin, their code would not work properly.
What's the difference? Means to call some basic classes underscore init underscore, while means to call a bound underscore init underscore from the parent class that follows some basic class's child class, the one that defines this method, in the instance's method resolution order, row. If the instance is a subclass of this child class, there may be a different parent that comes next in the row. Explained simply, when you write a class, you want other classes to be able to use it. Super makes it easier for other classes to use the class you're writing. As Bob Martin says, a good architecture allows you to postpone decision-making as long as possible. Super can enable that sort of architecture. When another class subclasses the class you wrote, it could also be inheriting from other classes. And those classes could have an underscore init underscore that comes after this underscore init underscore based on the ordering of the classes for method resolution. Without super, you would likely hard-code the parent of the class you're writing, like the example does. This would mean that you would not call the next underscore init underscore in the row, and you would thus not get to reuse the code in it. If you're writing your own code for personal use, you may not care about this distinction. But if you want others to use your code, using super is one thing that allows greater flexibility for users of the code. Python 2 versus 3. This works in Python 2 and 3. This only works in Python 3. It works with no arguments by moving up in the stack frame and getting the first argument to the method, usually self for an instance method or cls for a class method, but could be other names, and finding the class, for example child, in the free variables. It is looked up with the name underscore class underscore as a free closure variable in the method. I used to prefer to demonstrate the cross-compatible way of using super, but now that Python 2 is largely deprecated, I will demonstrate the Python 3 way of doing things, that is, calling super with no arguments. Indirection with forward compatibility. What does it give you? For single inheritance, the examples from the question are practically identical from a static analysis point of view. However, using super gives you a layer of indirection with forward compatibility. Forward compatibility is very important to seasoned developers. You want your code to keep working with minimal changes as you change it. When you look at your revision history, you want to see precisely what changed when. You may start off with single inheritance, but if you decide to add another base class, you only have to change the line with the bases. If the bases change in a class you inherit from, say a mixin is added, you'd change nothing in this class. In Python 2, getting the arguments to super and the correct method arguments right can be a little confusing, so I suggest using the Python 3 only method of calling it. If you know you're using super correctly with single inheritance, that makes debugging less difficult going forward. Dependency injection. Other people can use your code and inject parents into the method resolution. Say you add another class to your object and want to inject a class between foo and bar for testing or some other reason. Using the UN super child fails to inject the dependency because the child you're using has hard-coded the method to be called after its own. However, the class with the child that uses super can correctly inject the dependency. Addressing a comment. Why in the world would this be useful? Python linearizes a complicated inheritance tree via the C3 linearization algorithm to create a method resolution order, MRO. We want methods to be looked up in that order. For a method defined in a parent to find the next one in that order without super, it would have to get the MRO from the instance's type, look for the type that defines the method, find the next type with the method, bind that method and call it with the expected arguments. The young superchild should not have access to inject. Why isn't the conclusion always avoid using super? What am I missing here? The young superchild does not have access to inject. It is the young superinjector that has access to inject, and yet cannot call that class's method from the method it inherits from unsuperchild. Both child classes intend to call a method by the same name that comes next in the MRO, which might be another class it was not aware of when it was created. The one without super hard codes its parent's method, thus this has restricted the behavior of its method, and subclasses cannot inject functionality in the call chain. The one with super has greater flexibility. The call chain for the methods can be intercepted and functionality injected. You may not need that functionality, but subclasses of your code may. Conclusion. Always use super to reference the parent class instead of hard coding it. What you intend is to reference the parent class that is next in line, not specifically the one you see the child inheriting from. Not using super can put unnecessary constraints on users of your code.
I had played a bit with super, and had recognized that we can change calling order. For example, we have next hierarchy structure. In this case MRO of D will be, only for Python 3. Let's create a class where super calls after method execution. So we can see that resolution order is same as in MRO. But when we call super in the beginning of the method, we have a different order, it is reversed order of the mergeable. For additional reading, I would recommend next answers. C3 linearization example with super, a large hierarchy, important behavior changes between old and new style classes, the inside story on new style classes.
Doesn't all of this assume that the base class is a new style class? Will not work in Python 2. Class A must be new style, i.e., class A object.
In all cases, the evidence versus